Hey everyone, and welcome back to the Azure Database for MySQL monthly live webinar. I'm Dsouza. I'm a product manager with Azure Database for MySQL team at Microsoft. We are live today, as always, on YouTube, LinkedIn, and Twitch. And for those who might have missed any of our previous episodes, you can check out our session recordings in our YouTube channel. Our handle is at Azure DB for MySQL. Today, we bring you two deep dive topics on business continuity, disaster recovery, and switch from VNET integration to private endpoint for Azure Database for MySQL, flexible server, and also a public network or a public network. And a refreshed learning path on Azure Database for MySQL, and to end it all with all the updates on the roadmap. So the first session is Demystifying all BCDR options on Azure Database for MySQL by Avnish Rastogi, Principal Product Manager with Microsoft. And second session is a demo on how to transition from a VNet integration to public access or private link using Azure CLI command by Ramkumar Chandrasekaran, Senior Software Engineer, Microsoft. And the third session is on Azure Database for MySQL Learning Path, which is a refreshed, updated one by Shreya Aithal, Product Manager, Microsoft. And finally, I'll walk you through the upcoming roadmap and also talk a little bit about our presence at Microsoft Ignite 2024. Welcome to the webinar. If you have any questions or feedback, post them in the live chat and we'll get them addressed right away. One more thing before we get started, if you have any questions or feedback during the webinar, or if you just want to drop a hi and let us know about topics that you'd like to have covered in our future episodes, please leave a note in the live chat window and we'll address them as we go through the session. As usual, we have Shreya, one of our experts online, on monitor to chat window and help answer any questions about the product and the presentation that we don't get during the session. So now let's get started with the first session. When we talk to many of our customers, we often hear questions on HA and business continuity, disaster recovery capabilities, and find it complicated to choose the right option among the many. I'd like to welcome Avnish Rastogi, Principal Product Manager at Microsoft, to take you through all the various options, pros and cons of each, and help you choose the best option you need. Hey, Avnish, thank you for joining us today.
Thank you.
Could you please go ahead? Could you please briefly introduce yourself before we jump into the presentation?
Yeah, so I'm one of the PM in MySQL team. I've been with Microsoft for almost 7.5 years now. And before that, I spent with other companies and almost 13 years in healthcare. So I have a deep background on the healthcare side.
Great to hear that. Thank you, Avnish. I'll hand over the stage to you now for
Thank you.
the deep dive.
Yeah, so backup and restore or business continuity in general is one of my favorite topic. And I believe this is one of the key aspect of the database operations. We talked about backup and restore business continuity features in the previous session, but over the next 6 months, we added a lot of features, especially on the backup and restore. So we'll cover those features in next few minutes. And as you have any questions, please post it on the chat, and we will try to clarify those questions during the call. Next slide, Neil. So there are two aspects of the business continuity. One is the high availability, which gives you the protection against the regional outage. So, and in Azure MySQL, we support two HA configuration. And in either scenario, we support zero data loss failover, whether it's planned failover or unplanned failover. We do automatic failover in case of any outage on the primary instance. And the two options on the high availability same zone HA and zone redundant HA. Same zone HA doesn't provide you protection against the zone outage, but in with the zone redundant HA, if zone goes down, we will automatically fail over to your redundant or the secondary instance. Next slide, Neil. So this is the architecture of the zone redundant high availability configuration in Azure MySQL Flexible Server. We have availability zone 1, where your primary instance is deployed, and availability zone 2, where your standby instance is waiting for the failover. It's a no shared architecture, and we allow you to configure both primary zone as well as the standby secondary zone to ensure that your high availability configuration for your MySQL instance align with your application high availability, regardless of whether your application is deployed on Azure VM, Azure apps, or containers. In either case, you can configure both the primary zones as well as the standby zone. Now, this is a PaaS service, so underlying operating system should not matter to you as a customer, but we share this information with the customer, and we use Linux operating system, which is, and your MySQL instance is deployed on a dedicated VM. So the compute resources are not shared with any other customers. It's a dedicated resource, and all your data files and bin log files are stored on the premium file storage. Both primary instance as well as your standby instance has dedicated compute and dedicated premium storage to store all the required components. Your backup files are stored on a shared zone redundant backup storage, assuming it's configured with the zone redundant backups. We'll cover those options in a incoming slide. And now for the HA configuration, we are continuously copying your bin logs from the primary instance to the standby instance. And if it's a whenever there is a failover, whether it's planned or unplanned, we apply the remaining bin logs to make sure there is no data loss before we bring your standby instance online. Next slide, Neil. Now, in terms of failover, we guarantee 60 to 120 seconds failover time. That has been the P99 we have seen in most of the cases. In addition to that, as I mentioned, we guarantee no data loss failover. We support two options for the failover. One is the planned downtime failover or the forced failover, which is the option which you can use to understand how long your application will take to do end-to-end failover, which includes application failover as well as the MySQL instance failover. The second is the unplanned downtime. So if something happens to the primary instance or primary zone, or even we will automatically fail over to the standby instance, apply pending bin logs before we bring the standby instance online. Now, in case of unplanned downtime, failover time may vary depending on the bin logs we have to apply. In most of the cases, like I said, it takes normally 60 to 120 seconds to do the failover. Now for the backups, we have auto backups, and we do full backups every day, and then transaction log backups every 5 to 10 minutes, depending on the activities on your MySQL instance. In addition to the auto backups, we also allow you to have on-demand backups. And there are multiple use cases we have heard from the customer where we introduce this feature on-demand backup. And one of the key use case we have seen from the customer, when customer wants to do any kind of a critical patch on their application or on their database instance, they want to have a last successful backup which they can use for the rollback. So it with on-demand backup, just before your downtime or begins, you can initiate the on-demand backup, and we do storage snapshot. So these backups are very fast, normally less than 5 minutes, regardless of your database instance size, whether it's 1 terabyte or multi-terabytes. It normally takes less than 5 minutes to do the backups. And we support multiple redundancy options, including local redundant, zone redundant, and geo redundant. So in case of local redundant, we will have multiple copies of your backups in the same zone where your primary instance is deployed. When you do zone redundant backups, your backups will be copied in a secondary zone in the same region where we will have the multiple copies of your backup files. And finally, with the geo redundant, we copy those backup files from primary region to Azure paired regions, which could be different than your DR region. And we will talk about this in coming slide. When it comes to backup retention, we support between 1 to 35 days. And this retention applies to both your auto backups as well as your on-demand backups. When it comes to backup storage cost, and this is one of the question we often get from the customer, that how much I am paying for the backup storage cost. So when you provision MySQL instance, you will get free backup storage up to total provisioned storage at the time of provisioning. So for example, if you have provisioned instance with 1 terabyte storage, you will get 1 terabyte backup storage free of cost. And depending on the retention period and size of the instance, if you consume more storage, you will be paying for the additional storage after 1 terabyte. Next slide, Neil. Now, on-demand backups, as I mentioned, that typically it's the rollback strategy for many customers, whether it's application patches or database schema changes. And we support up to 50 user-initiated backups. The retention period would be same as auto backups. And with on-demand backups, we have seen that restore time is up to 90% fast than the auto backups. Um, and we have made multiple improvements in our restore. So restore itself is very, very fast now, and 1 terabyte doesn't take more than few minutes. Next slide, Neil. All this information in terms of the backup and how many backups have been completed successfully, what the retention period for each backup, all this information can be viewed through the backup storage, backup and restore blade, which you can see on the right of the screen. And you can also initiate the on-demand backup from the same place. Next slide, Anil. Now, when it comes to restore, there are two options from the restore. One is the point-in-time restore, and second is the geo-restore. Point-in-time restore is supported on, we have multiple options within point-in-time restore. One is the latest restore, which will allow us to use the last full backup and apply all the pending bin log files to bring it to the current point in time. Second option is the custom restore point. So let's say you want to restore your MySQL instance to midnight last night. In that case, again, we will use the last full backup and apply all the pending bin log files to bring it to the requested point in time. And finally, the fastest restore point. Fastest restore point is basically restore from the last full backup, and we don't apply any bin log files. It's normally handy for the customers who wants to have a instance for the testing on some other use cases, and they don't really care whether data in the restored instance is current or up to a certain point. They just want to have a schema ready and with some data for the testing and so forth. And finally, geo restore. So if there is an outage in your primary region and you want to restore your instance to another region, that's where you would have the geo backups ready to support that requirement, to meet those requirements. Now, there are two scenarios for the geo restore. One is the restoring in the paired region, but if your DR region is different than the paired region, you can still use the geo backups to restore your MySQL instance in any region where MySQL service is available, which is almost 90% of the region where MySQL service is available. Now, restore time in case of geo restore will depends on the size of the instance as well as the network latency. So if you're doing restore in the same region as your MySQL, where MySQL backups are restored, there would be minimum network latency. But if you restore in a different region, then there would be some network latency between the paired region and the region where you're trying to restore. So that's something to keep in mind, that restore time in this case may vary. Next slide. So we talked about geo backups as one of the option for the disaster recovery protection. The second option is the read replicas, which is also the managed feature from the service. And we support read replica in the same region where primary instance is deployed, or any other regions where MySQL service is available. There are two use cases we have seen for the read replica. One is the disaster recovery, and second is if you want to offload your read-only workload to the read replica instances. And in that case, you can provision read replicas in the same zone where your primary instance is deployed, or other zones in the same region. Now, when you are using the read replica as a DR, for the DR during the outage, whether it's planned or unplanned, you have to promote read replica to read write instance and reprovision the required read replicas, because the old MySQL instance is obsolete once you promote your read replica. And we have heard from multiple customers, especially the customers in healthcare or the financial industries, where they have the compliance requirement to test the disaster recovery every 6 months, or in some cases every quarter. Now, read replica requires multiple steps to do the DR testing. You have to promote the read replica, you have to update the connection string if you don't have any proxy SQL or load balancer in front of your MySQL instance. So you have to update the connection strings, and then you have to reprovision all the required read replicas you had before. So it's a it's time consuming if you're doing DR testing every 3 months, and it can take some time on the operational overhead. In that case, we also support a feature called data in replication, where we provide different Azure database procedures or MySQL database procedures, which you can use to configure the replication between your primary and the DR instance. And if you have a requirement to do the DR testing every 3 months, you can configure the replication between your primary instance and the DR instance, as well as the reverse replication from DR to primary instance, and configure your DR instance in the read-only mode. During the failover testing, all you have to do, switch your primary instance to read-only mode and switch back your DR instance from read-only to DR to read-write instance. And when you are done with your failover testing, you can reverse the role of those instances. So you don't have to promote the read replica or anything like that. And this process can be fairly automated almost 100%, just on a matter of click. Everything can be updated accordingly. Next slide, Neil. So in case of geo-redundant backups, we covered most of the points, but as I mentioned that your backups will be copied in the paired region, and for each Azure region we have a dedicated paired region. For example, East US2 might have Central US. In that case, your backups would be automatically copied in the Central US region. But you can use these backups to restore in any region where MySQL service is available. And RPO in this case, you may lose up to 1 hour data. And reason being because we are copying those backups regularly, but because of the network latency, we may not have all the backups required for the recovery. So there is a potential for losing up to 1 hour data in case of disaster recovery scenario. Next slide, Anil. Now, data in replication, as I mentioned that one of the use case for data in replication is when you have the compliance requirement to do the DR testing every 3 months or every 6 months. So data in replication can be configured between your primary and the DR instance. And your DR instance in this case could be in a different Azure region, or could be on premise. We have seen customers where They are using their primary on-premise data center as the primary region for the application workload, and Azure as the DR region, or vice versa. Azure is the primary place for the application workload, and their on-premise data centers are the DR. So in that case, you can configure the data and replication between your primary instance and the DR instance. And we support replication from Azure to on-premise, as well as from on-premise to Azure. So all the different use cases are supported using either read replica or data and replication. Next slide, Neil. Data out is just another way to say that replication. Data out, typically we use this terminology when you are trying to configure replication from on-premise to Azure, or sorry, from Azure to on-premise. Are there any questions, Neil, before we transition to RAM for the VNet and private endpoint discussion?
There are no questions at this point, Avnish.
Okay,
We
thank you.
can go ahead.
Yeah, I will stay online in case there are any questions for me.
So, thank you, Avnish. That was crisp and clear. When to use which option or mix and match to meet the business continuity and DR goals. Thanks again for taking us through this session and provide clarity with these complex features and joining early in your day.
Hey, looks like there's one question that has just come up from Santosh. I'm just going to flag it out here. It's Santosh asks, what is the proposed architecture for automated failover to secondary region in the event of primary region outage? I believe we've covered a bit of it, but can you summarize, Avnish?
Yeah, either option can be used, whether it's read replica or data and replication. Both can be automated. Read replica requires multiple steps, as we discussed, but these options can be 100% automated. And we have seen this with multiple customers to automate those.
Thank you, Avnish.
Thank you, Avnish. So moving on to the next topic of the day. Network connectivity is one of the hot topics which keeps coming up, and we have multiple ways you can connect to Azure Database for MySQL. While you get direct connectivity with a VNet with VNet integration, private endpoint helps simplify the configuration, taking out VNet maintenance and uh, the possibility of connecting from public access would even not exist there. But with private endpoint, that's an option. I'm inviting now Ramkumar Chandrasekaran, Principal Software Engineer, to explain and demo how easily you can move from VNet integration to private endpoint or public access. Welcome, Ramkumar.
Thanks, Neil. Happy to be here. My name is Ram. I'm a software engineer in the MySQL team, mostly working on connectivity related stuff. My previous experience has been in relational databases like Postgres, SQL, and now it's MySQL. So happy to be here.
Thank you. And I give the stage to you to take us through this session.
Thank you. Next slide, Neil. So if we look at the Azure Database for MySQL Flexible Server connectivity options today, right? It can be broadly classified into two categories like public access and private access. For public access, you essentially have different options, like you can allow access from a particular IP address range or a range of IPs using firewall rules that you can configure. You can allow access from Azure VMs as well. And these are some of the things which you can do to enable public access. And you enable public access when you want to access your database from the internet, the application from the internet, or external networks is also required, right? And so you will have to expose public access to your database. And this is the overall public access connectivity option that you have. The next option is private access, right? And with respect to private access, our product has like two options that you can choose from. The first is private link, which is like a sort of general concept with respect to Azure networking. Private link supports a lot of resources, like other resources as well, like SQL Server, Cosmos DB, and everything. It provides, it creates like a private endpoint for your database, which is like a specific private IP address, and you can connect to that private IP address from your VNet. And you can also integrate it with DNS zones to have like DNS records pointing to that private IP address. The second option that we provide for private access is VNet integration, in which you directly provide the VNet and subnet, and then the MySQL server is part of that subnet. You would have to delegate that subnet to flexible servers so that it's used for the sole purpose of just for flexible servers. You would have to do that before you choose this option. And this is also useful for intra-network communications, and when if you have other VNet peering, then this works as well. And when should you use private access is for high security environments where you need like restricted Azure access, and also there might be security and compliance policies in which you will have to keep your database private in cloud networking setups and all these things. Now but today what I'm going to talk about is this transition, right? We provide, let's say you have created a server with VNet integration, right? And for some reason, right, maybe your application requirements changed or something else changed, right? You want to move to public access or private link, right? We provide the option to do this, right? Rather than you restoring to a new server and doing this or a lot of steps, right? We directly have this option to move to private link or public access from VNet integration. And we have portal and Azure CLI capability as well. I'm going to show both in today's demo. Yeah. Next slide, Neil. Yeah, we can directly start the demo. And I have written a blog about this. That is what we have seeing here. So it enables you to move to public access or private links seamlessly without altering the server name or migrating data. This transition involves some downtime and you cannot reverse it. So please plan to do this when you can take the downtime for HA and non-HA servers. Approximately 5 to 10 minutes for non-HA servers and 20 minutes for HA-enabled servers for this transition. And we have like portal documentation on step-by-step instructions on how to do this via the Azure portal itself. Opening that link, and you can see like when you go to the networking blade for a VNet server, right? You'll see this option of move to private link button. And once you click on that, you'll see like two-step window opening. And the first step is to like detach the VNet, and then the second step is to create the private link. So you can go through this process and move to private link as well. And if you want to move to public access, just like detach the VNet and not like create the private link, and then you will move to public access. So this is all fine from a porter standpoint of view. But what if you have like multiple servers and you want to script this, right, in a bash script? And here we provide two bash scripts using Azure CLI to make this transition seamless. First script is MySQL VNet to public, which helps you to transition from VNet to public access. The arguments are give the subscription ID, resource group name, server name, and also the firewall rule name that you wish to add, and the range of IP addresses that you want to add for the firewall. This is just an initial firewall rule. Once the transition happens, of course, you can add more firewall rules to it if you need. But this is just getting all the parameters in a single place so that we perform both the operations, right? Detaching the VNet as well as adding the firewall rules in a single script, right? And then after the migration is successful, you can go and view the firewall rules in the networking blade. The second script that we are going to see today is migrating from VNet to private endpoint for the script with integration with DNS zone as well. And the similar kind of arguments, subscription ID, resource group name, server name, give like a private endpoint name, and also whether you want to create like a new private DNS zone along with this for the private endpoint. You can give it as true or false. If you're using custom DNS solution, then we can give it as false. If you want like an Azure DNS zone, then you can give it as true. And then once you run the script, we have the migration. These scripts are checked into GitHub here in this repo. I can point the link as well. So now, yeah, this is the GitHub repo that you can see the scripts. You can download the scripts and then run it on your machine. So today we'll download the scripts in Azure Cloud Shell and run it. I have created two VNet servers here for demo. MySQL VNet V1, which is like VNet integrated here. We'll be moving this to public. This is the private link button that I talked about. And then I have created another server, MySQL VNet 2, which will be moving to private link. This is also VNet integrated currently, and we'll be moving it to private link. So I'm going to open Azure Cloud Shell, which has like Azure CLI already installed. So it's very convenient to just directly run commands in the browser. So once we have this, I'm going to download the script, right? The MySQL VNet to public. Just get the raw content link, and then you can download it directly, the Azure Cloud Shell. Same thing, I'm going to download the script for MySQL VNet to private endpoint in Cloud Shell. Got it. Both scripts are now downloaded. And MySQL VNet 1 will be converting from VNet integration to public. So this is the command for that, running the script using bash command, give the subscription ID, resource group name, server name, and also I've given like a sample firewall rule name as well as the IP range that I wish to do. And what the script will do now is kind of detach the VNet from the server MySQL VNet 1. And after the detach is successful, it will enable the public access and also add the firewall rule on it. Yeah, now firewall rule is successful. Now that the migration is complete, you can click on the link here that is provided at the bottom to view the server networking blade directly and then see like what option is there. Previously, we saw MySQL VNet 1 was VNet integrated in the networking blade option, but now we see like public access is allowed, and you can see the firewall rule here that we added, right? Allow IP range. So that firewall rule is added, and now this MySQL server is enabled for public connectivity. Neil, can you go back to the video? I think we still have the video running. A little bit, this is a little bit far, no, a little bit front, even front. Yeah, we can have it here. So this is what enabling the public connectivity, transition from VNet to public connectivity. Now the next script is MySQL VNet to private endpoint. We'll be doing that for MySQL VNet 2 server with this command. I'm giving the thing private, and I given a private endpoint name of MySQL PE. And right now I have said like do not integrate with private DNS zone. But if you want to create DNS zone, you can also set it as true. This will get all the VNet and subnet details that is existing right now, and it will actually create the private endpoint on the same VNet and subnet, which it was integrated, and it will remove the delegation. It's important to remove the flexible server delegation on the subnet. Only then we'll be able to create private endpoints on it. And right now the script detaches the VNet, removes the delegation on the subnet, and then creates the private endpoint on the same subnet that it was VNet integrated on. Right now it's creating, yeah, the private endpoint creation is successful. And you can check the list of private endpoints in the networking blade at the end of the script. Yes, you can see the private endpoint that we created, MySQL PE here, and you can connect using the private IP address here, or you can also create DNS records or custom DNS zones, or you can have like DNS integration as well. After this migration, you can create multiple private endpoints as well after you have transitioned this as well. So yeah, now we have seen this whole demo of using Bash scripts and Azure CLI to seamlessly migrate your existing flexible server from VNet to public or VNet to private endpoint. These are the different links you can follow through the blog post and documentation as well as the scripts. Please do try out the scripts and let us know if you hit any issues. Yeah.
Hey, thank you, Ram. Love how easy it is to transition from VNet integration to private endpoint or public access. So thanks again for your time today, early in your day. And let's move on to the next topic of the day. We can move to the next slide. Okay, learning is core to being top of changing technology landscape in today's day. And here we have an update on our learning path to grow your expertise on Azure Database for MySQL and gain some cool XP points, badges, and level up your game. I'm now inviting my colleague Shreya Aithal, product manager, to take you through the new learning path and show you the ropes. Hey,
Hi,
welcome,
everybody.
Shreya.
Thank you so much for having me here, Neil.
Although you're not new to this webinar or this challenge, still tell us about yourself and before we get started.
Sure thing. Hi, everybody. I'm Shreya Aithal. I'm a product manager in the Azure Database for MySQL team, and I primarily look after developer experiences and migrations.
Thank you,
And
Shreya.
yeah, thanks. Take it from here. Today we're going to talk about this new learning path on Microsoft Learn. I don't know how many of you are familiar with what Microsoft Learn learning paths and training modules are all about. But if you're not new to Microsoft, then you're not new to this, right? That's usually how it goes. What it essentially means is a learning path is a very simple way for you to it's like a course which helps you walks you through in a very structural format to learn everything about a particular service or a particular topic. Now we are launching this new Azure Database for MySQL learning path with 6 training modules. Earlier, the first 3 modules have been there for a while. We've refreshed it to address all the new features that have come out. But the remaining 3 are new, and together these 6 modules give you starting from level 100 in the first 2 modules, to level 200 in the third, and real level 300 content in the fourth and fifth modules, and it even covers a little bit of migration in the sixth module. Now use the ak.ms link that I have mentioned in the that I've put in the top right corner, that is aka.ms MySQL learning path, or just scan the QR code that's here. And what that will do is land you on this page, which is the Microsoft Learn page. Now, can you zoom in on just the learning path, please? So in this learning path, what happens is we've got, just give me a second. All right. So in this learning path, we've got 6 modules, like I said, and it takes you around 3.5 hours to complete. You can just go ahead and click on start in the very beginning on the top. But for now, what I'm going to do is walk you through the entire set of modules, show you each of the modules and walk you through what they all consist of. So the very first module is the introduction to Azure Database for MySQL, where we discuss the various MySQL options on Azure, including on VMs as well as the PaaS service, which is Azure DB for MySQL. And we also talk about how to use them and when to use each of these options, and also give you a little bit of detail on the architecture of the PaaS service. The second one is my favorite module, which is deploy your first flexible server. What this essentially helps you do is there's an exercise module right here, which gives you the opportunity to deploy a server without having a subscription or anything. Any payment done. It's completely free. You get a sandbox that you have to activate and give a little bit of permissions here. And you essentially get 10 sandboxes in a day, and each sandbox lasts for 2 hours. Here you get a link on the top which takes you to the Azure portal, and you can follow all the steps mentioned in the learning path to create a flexible server. And not just create a flexible server, you can actually even look at the post create experience, walk through the features, and other functionality, and even learn. The next exercise right after this is an option to connect to the flexible server as well. Now, each module has a summary and a knowledge check as well, so you do need to pay attention to the modules. The third module is develop apps with flexible server. Again, has a exercise module. Here, you not only learn how to integrate with app service, deploy apps, but you also learn integration with services like Azure AI Search to build intelligent apps. So do give this a check as well. The fourth module is an advanced module, which explores all the advanced features in terms of networking, security, business continuity, and performance. And this module is actually goes along with the fifth module, which teaches you how to configure all of those features. So the fourth module is more of a concepts module, and this module is a how-to module for the same features that we discussed in the fourth one. And the last one is the migration one. After you're familiar with everything Azure Database for MySQL, understand the different phases for migration, the different considerations, and choose the right tool, because we've got a lot of them, right? Those who are familiar with Azure Database for MySQL have often come with the fact that there are multiple tools. Which one do we choose from? So you've got a decision matrix, and we also walk through one of the tools, which is the import tool as well. And once you're done with all of these modules, your learning path is marked as completed, and what you get is a badge that you can use to go ahead and share on social media, or post it and talk about it, right? So this is how a learning path works. Do try this learning path right away. It only takes 3.5 hours, so that's less than half of the working day. So do try it out, flaunt your badge, and tag us when you do that. You can just put an hashtag, or wait for a bit and look at the LinkedIn and Twitter handles of ours, and you can tag us as well. So go to ak.ms MySQL learning path and get started right away. Back to you, Neil.
Hey, thank you, Shreya. It was so cool to see that sandbox experience.
Perfect.
And next, we will move on to look at the latest roadmap on Azure Database for MySQL, and a little bit about what we are presenting at Microsoft Ignite. So next slide, please. So to start with, we have Azure Database for MySQL bindings in Azure Functions going in public preview in a few days. This will ensure native support for input bindings, output bindings, and a function trigger for Azure Database for MySQL Flexible Server. So it will help you to read data from a Azure Database for MySQL into a function, save the data back to the MySQL database, or even trigger a function when a change is detected in a MySQL table. And next is a MySQL discovery and assessment in Azure Migrate, which is currently in private preview. And this will help you discover MySQL servers in your infrastructure as a service or on-premise environment, or VMs as such, and go through assessment which will identify the compatibility of moving them to Azure Database for MySQL, and get some inputs on what should be the compute or storage SKU recommendations along with the costs. It will soon go to public preview in the existing quarter. And let's move to the next one is the MySQL version 8.4 support. So this is the latest LTS release from the community. It contains several improvements as described in the MySQL documentation. So this will go to public preview this quarter for you all to try it out and see and experience the new exciting features of 8.4. Next, as you're already aware, we have accelerated logs feature that went GA during Microsoft Build this year. It gives you double the performance of your business critical tier servers at no additional cost. Currently, this feature can't be enabled on servers that have customer managed keys or CMK. This limitation will be removed in the end of Q4 this year. Next feature is on-demand backup and export, currently in public preview. It provides you an ability to export at moment physical backup, basically snapshot backup of the server to Azure storage account, Azure Blob Storage, using Azure CLI. Once exported, these backups can be used for data recovery, for migrations, or for data redundancy and availability, or even for auditing purposes. So this will be generally available in Q4 calendar year 24. Next, a set of features with milestones in Q1 for next year, 2025. We'll have error logs in server logs now in public preview. This will provide you the option to view and download error logs under the server logs option for up to 7 days to analyze and troubleshoot issues. This feature will be generally available early Q1 next year, 2025. Finally, a couple of maintenance-related features, both with the next milestone in Q1 of calendar year 2025. One is a virtual canary, gives you new feature releases in preview. You can opt for your dev or testing or staging servers to be in virtual canary, where you get to see, you'll receive monthly updates in advance and gives you an opportunity to perform additional layer of testing on these updates in your lower environments on top of our internal tests to avoid issues specific to your workload or your application compatibility issues and the like. It's essentially an efficient way to manage updates, align dev testing, staging, and prod environments, and maintain a better operational stability with minimal disruption. And the second one is near zero downtime maintenance for HA-enabled servers. This is designed to reduce maintenance downtime for HA-enabled servers, ensuring that in most cases, maintenance downtime is between 40 to 60 seconds. It's crucial for critical businesses that cannot compromise on high availability and require minimal interruption in their database operations. And finally, the Azure AI search connector for MySQL. This is currently in public preview and also to be generally available in Q1 of 2025. Integrating your Azure Database for MySQL workloads with Azure AI search can significantly enhance the search relevance and user experience by leveraging advanced AI capabilities like vector similarity search and AI enrichment upon data ingestion. This integration also offers scalability, flexibility, and seamless integration with other ecosystems. It's widely adaptable to different AI-powered applications. So if any of you want to try out these features in private preview, please write to us at ask-AzureDB for MySQL at service.microsoft.com. We also publish a monthly update blog containing all the updates about our about 2 days after the webinar, and the latest updates will be available at ak.ms mysql-monthly-update. Before we close out, one other announcement that is about Microsoft Ignite 2024, which is right around the corner. The conference will be held in Chicago from November 19th to 21st. Do register today and join us. Alternatively, we can also provide a free digital pass to attend a few of the sessions and experience online. We'll be presenting 2 sessions, sharing really exciting announcements and demos in the community roundtable as well, sharing our journey of MySQL on Azure. So do add to these two sessions or these three sessions to your calendars right away. We'll also be present in person to connect with you at Microsoft Showcase, expert meetups, and answer all your questions you may have and sit with you to brainstorm ideas and solutions. So folks, that's it for today. As we close out, I'll leave you with four things. Check out our contributors initiative. Start contributing today and get badges, official recognition, and more. Secondly, to learn more about our service, you can use these resources or feel free to reach out to us on our email address. Thirdly, stay tuned for more updates and announcements by following us on social media and subscribing to our YouTube channel. Our handle is for YouTube and Twitter is at AzureDB for MySQL or at AzureDB MySQL. And finally, if you want to feature in our upcoming webinars or collaborate with us on any collateral, fill out this form and let us know. Also, you can use the same for any feedback on the session. If you have any requests or suggestions for the topics that we should be covering in the upcoming sessions, please feel free to fill this out. Thank you for tuning in. We hope you enjoyed the episode. See you all in our next session on the 13th of November at 7:30 a.m. Pacific time. Thank you and signing out.